Looking at where we are now, with our back to the sun and the planets, asteroids, and comets behind us, we face deep space. There's nothing between us and the stars that are very far away. Or is there? The empty space beyond Neptune is not empty. What if we tell you that the solar system is in the center of a giant ice cloud? This cloud might be filled with billions and trillions of comets and other objects. Before talking about this cloud, let's talk about what are comets. Comets are cosmic snowballs of frozen gases, rocks, and dust orbiting the sun. They are typically the size of a town. These comets, while orbiting the sun, get close to it and in the process are heated. Upon heating, they emit dust and gases into a giant glowing head. The dust and gases form a tail that stretches away from these for millions of miles. There are two main classes of comets: short-period comets, also called elliptical comets, and long-period comets. Short-period comets are generally accepted to have emerged from either the Kuiper belt or the scattered disk, which are two linked flat disks of icy debris beyond Neptune's orbit at 30 AU, and jointly extending out beyond 100 AU from the Sun. Short-period comets have an orbital period of less than 200 years and orbit the Sun in the same plane as the planets. Long-period comets have tilted and wildly elliptical orbits and appear from every direction in the sky. Their orbits last for thousands of years. The orbits of comets within the Kuiper belt are relatively stable, and so very few comets are thought to originate there. The scattered disk, however, is dynamically active and is far more likely to be the place of origin for comets. Comets pass from the scattered disk into the realm of the outer planets, becoming what are known as centaurs. These centaurs are then sent farther inward to become the short-period comets. There are 3,364 comets discovered so far. But there is a problem here. Comets lose material and burn up when they fly by the sun and melt in the spectacular process, which creates those gorgeous tails. After an interval of time, comets disappear, and yet new comets keep coming. It's been nearly 4.5 billion years to our solar system's birth, and yet these comets are still appearing from nowhere. So where are they coming from? And what makes them come towards us? This was a very puzzling question back in the mid-20th century. It was first theorized and solved by Dutch astronomer Jan Oort in 1950. He was also the first person to find the evidence for dark matter. He also found the distance of our solar system from the center of our Milky Way. To understand what he proposed, let's go a bit back in time, about 4.5 billion years back. Let's observe our solar system, coalescing out of a flat disk of material around the sun. The inner planets were warmer, smaller, and rocky, while the other planets were in a region that was freezing and grew huge. As this part of the solar system was chillier, water came in the form of ice mixed with dust and other stuffs. These pieces would then collide and stick together, and in the process, they grew bigger. So after the planets formed, the region in which they were formed still contained lots of these leftover chunks of ice and stuff called planetesimals. Planetesimals formed the same material as the planets did. But those outer Jovian planets, they had a lot of gravity, and any piece of chunk that got too close to them were either assimilated in them or got thrown into highly eccentric orbits. They were either thrown towards the sun or flung out into deep space. Trillions upon trillions of such ice balls got tossed around by the planets. These small chunks with a very little gravity pulled on the heavy planets, and the planets did the same. Though the gravitational pull of these small chunks of ice was not much, but after trillions of these encounters, it accounted. So the overall effect of all these encounters was that the Saturn, Uranus, and Neptune moved outwards, and Jupiter moved inwards. As Neptune was moving outwards, it had a lot of encounters with these ice chunks and flung them into wild elliptical and tilted orbits. This shuffling and moving of the outer planets is what caused the late heavy bombardment in our solar system. Today, there are three distinct populations of these objects. One is a region called the Kuiper Belt, named after the Dutch astronomer Gerard Kuiper. Comets in this belt have a stable orbit aligned with the planets. The Kuiper belt starts from beyond Neptune's orbit, extending for about 4.5 to 7.5 billion kilometers from the Sun. The second region is called the scattered disk, containing of those icy chunks that were flung into wild elliptical orbits by Neptune. It overlaps the Kuiper belt and extends for a distance of about 150 billion kilometers from the Sun. Finally, outside these two regions, there's a spherical cloud of these icy objects starting at roughly 300 billion kilometers and 65 times farther out than Neptune, and extends out to a distance of almost a light year. We call this the Oort Cloud, named after Jan Oort. Oort Cloud is the origin of long-period comets. In short, gravity from the planets shoved many icy planetesimals away from the Sun, and gravity from the galaxy likely caused them to settle in the borderlands of the solar system, where the planets couldn't perturb them anymore. And they became what we now call the Oort Cloud. The outer Oort Cloud may have trillions of objects larger than 1 kilometer, 0.62 miles, and billions with absolute magnitudes brighter than 11, corresponding to approximately 20 kilometer, 12-mile diameter, with neighboring objects tens of millions of kilometers apart. Its total mass is not known, but assuming that Halley's Comet is a suitable prototype for comets within the outer Oort Cloud, roughly the combined mass is 3 times 10 to the 25th power kilograms, or 6.6 times 10 to the 25th pound, or 5 times that of Earth. Earlier, it was thought to be more massive, up to 380 Earth masses, but improved knowledge of the size distribution of long-period comets led to lower estimates. No known estimates of the mass of the inner Oort Cloud have been published. Pluto was the first Kuiper belt object to be discovered. After 6 years, in 1992, QB1 was discovered, and we have discovered after that a lot of Kuiper belt objects. We can designate Pluto as a king of these Kuiper belt objects. While we know a lot of Kuiper belt objects, we don't know for sure about an Oort Cloud object. 2 very interesting objects, Sedna and VP113, have been found. They have a highly elliptical orbit, but neither of them are very close to Neptune. So how did they get there? They may be Oort Cloud objects that were disturbed by passing stars a long time ago, pushing them close to the Sun, but no one knows that. Another interesting point is that when astronomers calculated how many Oort Cloud objects should be left over since the formation of our solar system, they found it to be about 6 billion. However, when calculated using the observations of long-period comets, the number they found was about 400 billion. That was a big miscalculation they did. One idea about this was that there might be alien comets in our solar system from another solar system stolen by our Sun when it passed near other stars. There is another highly hypothetical explanation about this. There might be another planet in our solar system far from Neptune. Many long-period comets coming towards us are not random. Instead, they have their orbits aligned in such a way that looks like a distant planet disturbed them. Some of the Kuiper belt objects are also aligned in a similar way. This potential planet could be 10 times the size of our Earth, but we can't say for sure that there is a planet out there or not. We haven't been able to explore this region of our solar system. It's very far from us and also very huge. So huge that you could hide an entire planet out there and it would be difficult to find. We have to discover these realms and verify our facts with the help of every mission we could. Space probes have yet to reach the area of the Oort Cloud. Voyager 1, the fastest and farthest of the interplanetary space probes currently leaving the solar system, will reach the Oort Cloud in about 300 years, and it would take about 30,000 years to pass through it. However, around 2025, the radioisotope thermoelectric generators on Voyager 1 will no longer supply enough power to operate any of its scientific instruments, preventing any further exploration by Voyager 1. The other 4 probes currently escaping the solar system either are already or are predicted to be non-functional when they reach the Oort Cloud. However, it may be possible to find an object from the cloud that has been knocked into the inner solar system. In the 1980s, there was a concept for a probe to reach 1,000 AU in 50 years called TOW. Among its missions would be to look for the Oort Cloud. In 2014, announcement of opportunity for the Discovery program with an observatory to detect the objects in the Oort Cloud and Kuiper belt called the Whipple mission was proposed. It would monitor distant stars with a photometer, looking for transits up to 10,000 AU away. The observatory was proposed for halo orbiting around L2 with a suggested 5-year mission. It was also suggested that the Kuiper observatory could have been capable of detecting objects in the Oort Cloud. Thanks for watching, everyone. What do you think about these interesting theories and existence of a secret planet out there? We know this would take some time for you to digest, and we will answer any of your doubts related to this topic as best as we can in our comment section. Let us know about your doubts in the comments below. Be sure to subscribe, and we'll see you next time on the channel.